Today we're going to start talking about reaction mechanisms. So hopefully you remember that elementary reactions happen in a single step, but most reactions are going to take multiple steps in order to be able to have the correct collisions occur based on their molecularity. Don't forget that unimolecular is just one molecule that is reacting. Bimolecular is two molecules, and then trimolecular would be three or more molecules, but that's very unlikely because of having all three of them collide at the exact same time in the exact same orientation that you need is very unlikely. So let's look at an example for a multiple step reaction. Let's look at ozone. Ozone can decompose into O2 and oxygen, and then that lone oxygen can react with another ozone molecule to form another two oxygen molecules. So these are our two steps, and each one of those is an elementary reaction on its own. So this would be unimolecular, this would be bimolecular. But when you put them together, they're going to add up to create the overall reaction. So you would put all of the reactants. We have one single oxygen by itself and two ozones on the reactant side. And on the product side, I have three oxygen molecules and a single oxygen. And the single oxygen is the same on both sides, so that cancels out. So our overall reaction is 2O3, yields 3O2. The oxygen, the lone oxygen atom, is an intermediate because it is a product of the first step that becomes a reactant in the second step, and it is not present in the overall reaction. So make sure that you're able to identify intermediates. Let's look at another multi-step reaction. Let's say we've got chlorine reacting with ozone to form ClO and O2. And then the second step would be the ClO reacting with oxygen to form chlorine and O2. Now in this one, again, we're going to add up the two steps of the reaction. Both of these are bimolecular elementary steps. When you add them together, you want to put all of the reactants on one side, and then all of the products on one side. I can combine those two oxygen molecules. And then anything that is the same on both sides will cancel out. So in this case, it's the chlorine and the ClO. So my overall reaction is ozone plus oxygen yields 2O2. So we have two things here that are canceling out. The ClO is an intermediate. So it is a product of the first step that becomes a reactant in the second step. So it's kind of present in between the two steps. The other one, so chlorine, is what we call a catalyst. Now, we've talked about catalysts. Catalysts speed up a reaction by lowering the activation energy. They can also help by providing these multiple steps. Okay, so by acting as a catalyst here, it allows the reaction to proceed via these two steps written here. Now the chlorine is considered a catalyst because it reacts in the first step, but then it is reproduced by the end of the reaction. So a key feature of catalysts is that they're not present in the overall reaction because they are present at the very beginning and at the very end. So they cancel out. They're reproduced. So catalysts are not used up over the course of the overall reaction. Okay, so here's another example using nitrogen. So it says, which mechanism below is a valid mechanism for the reaction shown above, and explain your answer. The first thing you want to do is check to make sure both of those mechanisms add up to this correct overall reaction. So in the previous examples, I went ahead and showed how I would put all of the reactants on one side and all the products on the other side. In reality, what I do is I will cancel out things that will cancel out first, and then I add up what is not canceled out. So this N2O2 is a product and then a reactant. So that's an intermediate, but it will not be present in the overall. And then the oxygen is also an intermediate because it's a product and then a reactant. So that is not used up. So my overall reaction here is the 3 NO molecules on the reactant side producing 2 NO2 molecules on the product side. Which isn't even a balanced reaction, so that's not really a good mechanism. So it's going to be mechanism 2, but let's take a look at it. So again, I want to cancel anything that's the same on both sides. The NO3 is an intermediate here. And that's the only thing that cancels out. So there's 2 NO molecules plus an O2 molecule yields 2 NO2. So this one, of course, is the correct overall reaction. So mechanism 2 is the valid answer. If you were to put this in a free response answer in that claim, evidence, reasoning format, your claim is that mechanism 2 is the valid mechanism. Your evidence would be showing the correct overall reaction when you add them up. And then the reasoning would be that the overall reaction for mechanism 2 adds up to the same mechanism for the balanced chemical reaction that they were asking for.